Welcome and thank you so much for joining me today. So we are going to be looking at solving simultaneous equations with quadratics. Simultaneous means that we're having more than one equation at a time, and we're trying to find where they intersect. So for us to find where they intersect, we need to think about, okay, well, what's common about them? So we are going to substitute them both equations into one equation, and that will assist us to eliminate one of the variables, and then we're left with one variable, and that will let us be able to find that value, and that value will tell us where they intersect. So to start off, it makes it easy that they both equal y. So I can straight away go 2x equals x squared plus 5x take 5. I've substituted one equation into the other. Now, I want to get everything onto one side, and so it's in the form of ax squared plus bx plus c. So that means to get this to the other side, I need to take 2x from both sides. So I'll take minus 2x, and I will minus 2x on this side. And that just allows me to rewrite it as x squared plus 5x take 5 take 2x. Now we have a like term there. We have 5x and minus 2x. So we need to simplify to make our job easier. So 5x, and I've taken away 2 of those x's, and I'm left with 3x. And it becomes x squared plus 3x take 5. Now, there's 2 ways I am able to find the x values. One way is I can factorize. The second way, I can use the quadratic equation formula. And that is derived from me moving all of my variables around from the basic quadratic equation. So if you don't know if you don't know about that formula and how to get it, make sure you have looked at my proof. So I'm just going to think that ax squared plus bx plus c, and I'm using the formula that I've proved of negative b plus or minus the square root of b squared take 4ac over 2a. And then I just need to substitute everything into this equation. So b is 5. B is 5, so 5 squared. Oh, I'm looking at this one. 3. B is 3. 3 squared minus 4ac. 4a is 1, c is negative 5. 4 times 1 times negative 5 over 2 times a, and a again is 1. So now I've got my equation, I can simplify it. So I know I've got negative 3 at the front, plus or minus. 3 squared is 3 times 3, which is 9. Minus negative 4 times 1 is negative 4. Negative 4 times negative 5, so straight away it will be changed to a positive. 4 times 5 is 20. Divided by 2 times 1 equals 2. So I know 9 plus 20 equals 29. So that gives me 2 of my values. Negative 3 plus the square root of 29 divided by 2. And I'm also given negative 3 minus the square root of 29 over 2. If you wanted to, you can use the decimal of square root of 29, which is 5.38. I'm going to do that. 5.38. If you want an exact then use the square root, but I'm not too fussed about having exact with my answer, 5.38. So now we go, -3 plus 5.38 divided by 2 equals 1.19. 1.19. And my other x value will be -3 minus 5.38 divided by 2, which is -4.4. So now I've got my x values. The next thing that I need to do is substitute them into one of these equations. Now I'm going to substitute them into this equation here. So if x is 1.19, I'm just going to go y equals 2 brackets 1.19, and if my x is the other value, 2 times -4.4. So 2 times 1.19 equals 2.38. And 2 times -4.4, -8.8. So if we go back to this question, we're solving simultaneous equations with quadratics and where they intersect. So I know they are going to intersect when we have an x of 1.19 and a y of 2.38. And I also know that are going to intersect when we've got an x of -4.4 and a y of 8.8. Really hope that helps you understand how to solve simultaneous equations and work out where they intersect. If you need any extra assistance, feel free to message me and I'll make a video just for you.